Alright, last stretch. We are going to look at two more example problems in this op-amp chapter and we are done. But by now, you should be very familiar with the general process that we usually take when solving any op-amp problems. Okay? So, two more example problems. Let's solve them. Now, if you think about this, here is the first example problem, and this is from difference amplifier. Okay, it's called a difference amplifier because an input is applied to the inverting terminal and another input is applied to the non-inverting terminal. So this is the first example, this is the first configuration where input is applied to both the inverting and non-inverting terminal. Okay, and then the result was that the output is a weighted difference of both the inputs. Okay. And of course, like all other configurations in this course, the output is tied back into the input. Okay, because the output is tied back into the input, we call this a negative feedback configuration. Okay, so now the question is the first part of the question is, write the expression for VO, as a function of VA. Okay, VO is the output voltage, VA is the input voltage on the non-inverting terminal. Okay, how do we go about that? Here is my strategy. Okay, if I know a value for Vn, okay, then I should be able to write KCL at that node. But how do I know the value for Vn? Well, simply by knowing the value of Vp, that is the same as the value of Vn. Okay, so again, we have seen this circuit in the past, similar circuit. What is it called? Okay, 2 kilo ohms and 8 kilo ohms. There is Vp and there is no current flowing into the op-amp. So when we are writing KCL or trying to do the equation, two resistors, okay, just two resistors. We are interested in calculating Vp, which is simply a voltage divider. Okay, so the first thing I need to notice is, in order to find the expression for V out as a function of VA, I start by noticing that Vp is a voltage divider. Vp is really 2k by 2k plus 8k multiplied by 5 volts. Okay, that's this guy. That's the 5 volts here. So Vp is 2 by 10, 0.2 kilo ohms times, well, it's actually 0.2 multiplied by 5 volts. Vp is 1 volt. Voila, we have our Vn now. Vn equals to Vp. Okay, Vn is equal to Vp because of the virtual short. It's a constraint, right? So Vn equals to Vp. Now we can go about doing our step 1. which is KCL at node Vn. Okay, at node Vn, there is one current flowing in this direction, there is zero current flowing in that direction, there is one more current flowing in this direction. The current flowing left is Vn minus Va over 5 kilo ohms. Okay, so let's write that down there. Vn minus Va divided by 5 kilo ohms plus, what is the other branch current? Okay, this guy. Vn on this side, Vo on the other side. So Vn minus Vo over 20 kilo ohms. Right? Everybody with me? Vn minus Va, Vn minus Vo over 20 kilo ohms. Okay, that should equal 0 according to KCL. Okay, Vn minus Vo over the resistance over here. Okay, so now all of that should equal 0 according to KCL. Right? Dang it. Okay, let us see if we can fix this. Okay, it's easier to multiply the whole damn thing by 20k. Okay, so 20k by 5, so we have a factor of 4 times Vn minus Va. You know what, I'm going to replace Vn with a value of 1, no prizes for guessing, plus 1 minus Vo equal 0. Okay, so you simplify this expression, 5 minus 4 Va will be your V output. Cool, that's what we wanted to find. Okay, the first problem asks us to find the expression for Vo as a function of Va. Right? Find the expression of V out as a function of V input or Va. It's exactly what we did. Okay, 5 minus 4 Va is V naught. Okay, let's see problem B. Okay, what does B say? Va is 2 volts. What value of RF will saturate the op amp? Okay, what value of, you know what? I'm going to simply copy all of this. Copy all of this. Okay, and paste it over here so I can use it for my reference. I'm going to make it smaller. Okay, now let us see. Here is the idea. Va is given to be 2 volts. Va is given to be 2 volts. 2 volts. Okay, now what we have to find out is the value of RF that will saturate the op amp. Let's see if we can do that. How do we go about doing that? Let's go back to this. Okay, so here the value of RF is not 20 kilo ohms, it's unknown. Okay, so all I'm going to do is to copy this equation, pay close attention here, copy this equation, paste it over here. So this is KCL at node KCL at node Vn. Okay. Now earlier I had a value for RF which was 20 kilo ohms. Now this is not known, 20 RF. Okay. Also now we know the value for VA. Okay. VA value is given to be 2 volts. So let's plug all of that in. We know the value of Vn to be 1 volt. VA is negative 2 volts. Okay, negative 2 volts divided by 5 kilo ohms plus Vn is 1 minus VO over RF equals to 0. Okay, we can simplify this. Minus 1 by 5 kilo ohm plus 1 by RF equals to you know what, let's multiply, let's continue, VO over RF, multiply the whole expression using RF. Okay, now multiply the whole expression, both sides of the expression, by RF. Negative RF by 5 kilo ohms plus 1 equals to VO. Now we are getting somewhere. Okay. Now negative RF over 5 kilo ohms plus 1 for the op amp to saturate. Okay. For the op amp to saturate, the V output should be negative 10 volts. Okay. The V output should be negative 10 volts. Okay, that's because negative VCC. Okay, I'm not worried about positive 10 here because there is no way that this term, okay, this term will not exceed positive 10 volts, because you see there is a negative term in a resistance. Okay, so the resistance the total resistance is always going to be less than 1. Okay, or the total voltage is going to be less than 1 volt. Okay, so I'm not worried about positive saturation. I'm only interested in calculating the negative saturation. Okay, so now take this one to the other, take this one to the other side, manipulate the equation. Negative RF over 5 kilo ohm equals to negative 11 volts, and then RF, when your RF equals to 55 kilo ohms or larger, okay, when the RF value is 55 kilo ohms or larger, your op amp will saturate. And like we saw, it saturates in the negative side, negative saturation. Okay, pretty straightforward. Two problems, two parts of the problem we discussed. The first part is simply the application of KCL, and then finding an expression for VO as a function of VA. The next problem is finding the value of RF that will saturate the op amp, and it's pretty straightforward to calculate these both. Okay, I will see you with the next and last problem of the chapter.